SOLAS for Missing Data Analysis 4.0 Predictive Mean Matching Method Example Video. We will now multiply impute all of the missing values in the dataset using the predictive mean matching method. From the Analyze menu, select Multiple Imputation and then the predictive mean matching method. The Specify Predictive Mean Matching window is displayed. The window opens with two tabs, Base Setup and Advanced Options. The Base Setup tab allows you to specify which variables you want to impute and which variables you want to use as covariates to estimate the predictive equation. Drag and drop the variables to be imputed into the Variables to Impute field. In this case, sepal width and petal length. Drag and drop the covariates into the Fixed Covariate field. In this case, sepal length and petal width. The default number of imputations is 5. And this can be increased or decreased here. For this example, we will also select a grouping variable, species. The non-monotone and monotone tabs allow you to add or remove covariates from the model used for imputing the non-monotone or monotone missing values in your dataset. You select the plus or minus signs to expand or contract the list of covariates for each imputation variable. Variables can be added and removed from this list of covariates by simply dragging and dropping the variable from the covariate list to the variables field and vice versa. Even though a variable appears in the list of covariates for a particular imputation variable, it might not be used in the final model. By default, all of the covariates are forced into the model. If you uncheck a covariate, it will not be forced into the model, but will be retained as a possible covariate in the stepwise selection. The donor pool page allows more control over the random draw step in the analysis by allowing the user to define predictive mean matching subclasses. The following options for defining the predictive mean matching subclasses are: divide cases into a specified number of subsets. The default is 5. Use a specified number of closest cases. This option allows you to specify the number of closest cases that are to be included in the subset. Or you can define a percentage of the dataset closest cases. This option allows you to specify the number of cases as a percentage. When you use a refinement variable, the program reduces the subset of cases included in the donor pool to include only cases that are close with respect to their values of the refinement variable. You can also specify the number of refinement variable cases to be used in the donor pool. For this example, we will use all of the default settings in this tab. The Advanced Options tab allows the user to control the settings for the imputation. The main seed value is used to perform the random selection within the predictive mean subset. The default seed is 1, 2, 3, 4, 5. If you set this field to blank or set it to 0, then the clock time is used. The output log is a comprehensive list of regression equations, etc., that have been calculated for the imputed variables. The value set in the tolerance data field controls numerical accuracy. The tolerance limit is used for matrix inversion to guard against singularity. You can select F to enter and F to remove values from the scrollable data fields, or enter your chosen value. If you wish to see more variables entered in the model, set the F to enter value to a smaller value. The numerical value of F to remove should be chosen to be less than the F to enter value. When you are satisfied with all the SOLAS selections and settings, click OK and SOLAS will perform the multiple imputation. In this example, SOLAS generated 5 datasets with imputed values. These different datasets can be explored through the tabs at the end of the screen. The newly imputed values, shown in red, are in the monotone pattern, while any values appearing in light blue are in the non-monotone pattern.